So I guess we should begin. I will.
And what about the Facebook people?
Oh yeah. If you are, let me just make sure that's working. If you're joining us from Facebook, please put your questions in the comments on Facebook. I will hopefully, if I can monitor this. It's not my strong point. I will. Let's see if it's here. Yeah, it's here. So I will. If you are watching this from Facebook, please give us your questions in the comments, and I will answer the. I'll ask Karen those questions.
We'll go back and forth. Yeah,
Thank you for. Yeah, well, I'll toggle.
You'll toggle. Yes,
yeah.
That sounds good.
Jean is here from Maryland. Maurice here too. She's looking forward to COVID updates. So yeah, please, any topic. There's no topics that are off that are not allowed. It's just that Karen may not answer all of them. And just as my disclaimer that we like to say when we start these things each week. By the way, this is I'm recording. That's good. This is part 5. This is the 5th week that we've come together with this coronavirus conversation. So I'm so grateful to everyone who has participated. Love that we have Karen as our resident expert scientist. Karen, however, is not a medical doctor. So if you have a medical challenge of some sort, please call your doctor, call 911. Karen cannot answer medical questions. She is a scientist and will answer questions from a scientific perspective.
Good.
Sound fair?
As we always say.
So let's have some fun. Ask your question. Marge is here from Idaho. How cool is this? We have you're in DC, we've got Idaho, we have Maryland. I don't see any of our African friends here yet, but maybe they're.
Yeah, they're probably on Facebook. They prefer Facebook when it's possible.
Okay. All right, cool. So Karen, do you want to just start and give us a State of the Union? Do you want me to start with a question?
Sure, I can just, talk about a couple of things that were trending this week and a little bit about that article you sent me that you were interested in. So we've been saying from the beginning that what we don't know really is the prevalence of this infection in the population. The testing is highly skewed to those who are strongly suspected of having the disease, people who are really ill, and sometimes you can't even get it unless you're showing symptoms. And it's sporadic from state to state. Certain random people are getting tested in different places. So we have a real important problem right now. And this is impeding our ability to, start slowly reopening. We just don't know who had it, how many cases there really were. There could be anywhere from most likely 5 to 10 times as many true infections as we are reporting on the trackers and as we are identifying through testing. Many people are just toughing it out at home. They've got all the symptoms and they don't care to get tested. So here's the reality of what we've been learning. And why is this important? Well, if a lot more people were infected than we think, then the fatality rate of this virus is a lot lower than we think. So there were three, I think, very telling things that came out this past week. There were 2 studies, one in Germany and one in Iceland, and they tested random people. They sampled randomly, which is the right way to do it, to get a population estimate. They didn't do it in the whole country. They chose a few specific places, but they were finding a huge number of asymptomatic people. They estimated that 13 to 15% of the entire population in those areas had actually gotten the virus, and the majority didn't get sick.
Wow.
Now, this is even more interesting. You remember the aircraft carrier where the captain, got fired? They tested every single soldier on that ship. There were 6,000 people. And guess what? 60% tested positive, okay? And that's in a case, they're on a ship. So that's going to spread, they're in close quarters. But
Positive with the actual disease or with the antibodies?
No, no, I believe it was the PCR test.
Wow.
Okay. It could have been antibodies. Honestly, I don't know. But nonetheless, the report was that 60% of those sailors were positive and less than 500 were symptomatic. And to my knowledge, there hasn't been any death yet. Again, it's a fairly young population. Another encouraging piece of news is in the US, according to the numbers we have for COVID deaths, and as you may know, New York just added a ton of cases that were assumed COVID but had never been confirmed by any form of testing. So even with those guys, we are seeing that less than 1,000 people under the age of 50 have died, and virtually all of them had some kind of comorbidity. There was some underlying problem that they had. So I think that should be very encouraging for reopening, especially if we're protecting the vulnerable and we're letting the healthy, young people kind of return to work. Of course, there's always the risk that somebody's got an underlying condition they're unaware of, and COVID brings it to light. You'd have to be upset about that. But the US is lagging dramatically behind even European countries. Austria has started, slowly opening, Germany as well. But these guys have got far, far deeper testing penetration than we have. We're also noticing a little something interesting about our peak. We really have flattened the curve. Now, when you just go crazy, it goes way high and it peaks very sharply and comes down. When you flatten the curve, it goes up, but then it stays up a little bit and then it starts to go down. Right now, we're kind of on that top of the flat curve, okay? We're heading in a good direction, and I can just pop over to one of our trackers and show you that indeed, at least with confirmed cases, we're making progress. Okay, I'm sharing the screen. Now let me get over to the tracker. Okay, so this is one that I use, and hey, it's promising. You see that the US is starting to turn over. You can see Spain, the UK is not quite to where we are, but this is a good sign. However, let's not forget that we're a population of only 300, I think it's about 330, maybe 350 million people. At the most, maybe 380. That's not a lot. China is 1.4 billion, okay? And we have a third of the cases in the world. That definitely says something about public health failures. And one of the things we've really got to do better going forward is get our public health infrastructure rebuilt. And I think there's something in the risk management field that says we tend to fear the unknown and the scary more than the familiar, which can often be very, very risky. At the end of the day, we may find out that COVID has a fatality, an infection fatality rate well below 1%. It's looking to be 0.4 in some of the countries that have done a lot of testing. Very likely. Influenza is about 0.1 on an infection basis, but we have a lot more of it, right? We tend not to fear it. We don't invest in it. Do you remember when we had West Nile virus a while back? It was maybe about a decade. Yeah. West Nile, by its nature, was only going to be dangerous if you're a horse or a cow. Okay, it was dangerous for animals. It was never going to be a serious human health problem, and we've invested 10 times more in researching a vaccine for West Nile than a universal vaccine for influenza. And does that make sense? Now, COVID is clearly a threat, and it's a serious one, and I know we'll take it seriously. But I hope we all, you know, as this is said and done, we all can kind of step back and really, you know, make a ranking and prioritize. COVID is definitely at the top of the list now, but closely followed by some pretty nasty influenzas that have the potential to do this kind of thing that we've seen. But luckily we have a vaccine, okay? Now, another thing that was trending, and I think everybody's probably read this, we probably will be able to start opening up by the end of May to some extent, but this is going to be an up and down thing. You know, we may have another wave. If we get a respite in the summer, we could see a second wave in the fall. So we have to really prepare to do things differently until we've got that vaccine and or herd immunity.
Karen, I have a question for you. Why is it that the European countries are deeper in terms of their work and their research, and they're getting out of the tests? Like, why is it such a challenge in the US?
Well, again, most European countries are a little more, shall I say, socialist. And they've had stronger public health systems than we do. They have better social safety nets. A real center of strong coronavirology research is Germany and the Netherlands. Okay, they're kind of at the top, and you know, they've been aware of this. I mean, they were in the forefront for SARS. The Asian countries were hit very bad with MERS and the first SARS, so they weren't taking any chances. Taiwan in particular did very well, as did South Korea. So we simply, okay, first of all, the tests rollout, there was a contamination in the CDC. The initial tests all came from the CDC, and some of them were faulty, right? Right now, we have a lot of antibody tests floating around. Not all of them are validated. Not all of them are reliable. As simple as they are to use, some healthcare providers aren't used to them and just haven't been doing the correct thing with them. So there's a lot of issues there, but people are on it. They're working on it. You know, testing, there are places now, the CDC revised some testing guidelines, and there are places where test kits are going unused. And that's a little bit problematic. I think they were concerned that they might need them for another spike or a resurgence. But I think, you know, if someone is symptomatic and shows up at a testing center, why not give them the test if they're available? That would help us get a better sense of the prevalence. And I bet we're going to see, when we go back to work, we may even see workplace testing stations, like if your workplace has a clinic associated with it, or, you know, there's a nurse in the school, you might see this kind of thing. I definitely predict a massive change for the next couple of years until we do have that effective vaccine.
I mean, it's pretty crazy having experienced the taking of the test, not personally, but my son doing it and my brother administering it, who is not a doctor.
It's so simple,
and
really.
It's so simple. And it's like, you know, why not just empower people to test themselves? Like, if they want to get their hands on a test, like, let people test themselves to some extent.
Yeah,
so,
I mean,
you know, and then select to share their data, right? Because like this thing where it's like, you know, you have to go through hoops to some extent to get the test is crazy. So I have a neighbor who's 85 years old. She's a healthy 85-year-old, but she'd been sick for about a week, and she left the building, and my other neighbor saw her, and she was going to the hospital because she thought maybe she had COVID. The hospital sent her home.
Wow.
They sent her home.
Okay.
They did not test her. You know, and it's like, you got to think, they're not testing her.
This is really problematic.
Who's getting tested?
There's no doubt. Yeah, exactly. And California's doing better than most states. So So again, the CDC is hiring. We're ramping up contact tracers, but we're already playing catch up. We were since January. And as we've talked about before, the dismantling of our public health infrastructure under both Democratic and Republican administrations has been ongoing since the 80s. I think we were overconfident that we had licked this kind of thing. But I do want to say one thing. I've heard some journalists saying crazy stuff. Okay, here's one crazy thing. And this is where when you don't know history, you can make some serious mistakes. One journalist was saying, wow, this coronavirus, you know, I'm paraphrasing, we haven't seen anything like this in human history. Well, don't make me laugh. This is the norm in human history. The bubonic plague, smallpox, yellow fever. I could go on and on. This is the norm, and we are getting hit with something that most of our ancestors took for granted. There was a saying, you know, a couple of centuries ago, don't count the number of children you've had until they've all had the pox, right? Because how many were going to survive that? And influenzas, I mean, there's a lot of nasty influenza out there, and we just aren't investing enough. I don't know if a universal vaccine is even possible for that. We could try it. We could look at it a little harder. You see, most vaccines target what we call the antigens from the viral attachment protein. And in influenza, there are 15 different ones, okay? And they shift all the time. An influenza with its segmented genome reassorts. I think that swine flu in 2009, that was very bad. If you got bad swine flu, it looked just like what we're seeing now with COVID-19. And that was, I think, was it an H7N9 or an H9N6? One of the two.
I thought swine was H1N1.
No, that's the so-called, yeah, that's a different one. That's also swine. There's many different kinds.
Got it.
There are 15 different, at least as far as I know, there could be more by now, 15 different H, which is the equivalent of that spike protein that we talk about for coronavirus. And then there's an N. Now the N is also important. It's an enzyme that cleaves something to allow the virus to exit the cells it's been replicating in. And, you know, it really helps for exit and entry into the cell. So it's important, but H is critical. Without, if it had no H protein, it couldn't get in the cell except by a general membrane fusion, which is a pretty rare and it's not a common event. A virus that depends on that entirely has a real hard time becoming a problematic virus.
So anything else on sort of the state of the virus?
Okay, there's two more papers. This is kind of maybe more technical than people want to get, but I assume people have heard it's a Chinese bioweapon. It's a US bioweapon.
Yes, I've read the articles.
Well, two papers came out this past week in two very prestigious journals. We do have the ability to genetically engineer viruses, and we do it all the time to study them and learn about them. Now, let me just say, kind of generally speaking, there's like a backbone, like a genetic backbone. If you want to do bioengineering of a coronavirus, there's maybe a dozen of them, maybe more, that you would use, right? You would use that, and that would be your scaffold to build up the virus. It isn't any one of them, okay? And then others have done what's called a phylogenetic analysis, and they've traced its evolution. This thing has things in it we would never think of. And it's only slightly different from naturally occurring things. So we suspect it got out of a bat, maybe passage through a pangolin, could have passage through a human. We just don't know. And there's kind of a disturbing thing now. You probably have read that there's what we call a BL4 virology lab in Wuhan. And there's some thoughts. I mean, we cannot, We cannot tell if this escaped from a lab. What the person who runs the bat viruses division has said, I mean, she's published even a popular article in Scientific American, and she has looked at her strains. Now, what does that mean? It means the viruses they save and collect and work with, it's not one of them. But they work with bats all the time. They work with small rodents, mammals. Who knows if someone was dissecting a pangolin or a bat and didn't self-infect, totally accidentally. Now, what's problematic? We call these labs, okay, there are 4 biosafety levels. Biosafety level 1, that's kind of like your junior high lab almost, your high school lab where nothing's going to happen. Then BL2, that's the level I worked at most of the time. These are things that don't generally cause severe problems. You could cut yourself, you could have an accident, but it's unlikely to more than make you a little bit sick for a while. There aren't fatalities. Now, at every level, the precautions and how you have to dress and how you have to handle pathogens gets more stringent. Now, you go up to BL3, and that's where you've got HIV, you've got some serious viruses, and generally speaking, every year, if you have an accident in a certified lab, you have to report it to the CDC. So there are so many accidents at BL2 and BL3. I'm not sure BL2 accidents have to be reported, but 3s do. And, there are very, very, very few fatalities. Probably a couple, I'll say, out of maybe thousands of incidents. Now, BL4 is a whole different kettle of fish. That's the really serious spacesuit labs that you see in movies, right? In general, there are 6 accidents in US BL4 labs in a year, probably all of them fatal, or 80 to 90%. So this is pretty serious pathogen work. So, and generally things don't get out of there. So if a BL4 facility in China wasn't observing proper precautions and this really escaped from a laboratory, I don't know, it's tragic. I hope that won't turn out to be the case. I know that particular lab had been cited before for like some laxity in its precautions. So what kind of pathogens do we see in BL4? This one, for example, though this one is probably being worked with at BL3 now because we understand enough about its characteristics. Things like hemorrhagic fevers, Ebola, Yersinia pestis, which causes Black Plague, that kind of thing. I mean, there's not, to be honest, I believe there's a BL4 at USAMRIID. There's one in Galveston, Texas. I think there's one somewhere in the upper Midwest. There's one in England. Those are the only 4 I can name. They're so difficult to construct. They have to be away from, you don't want them really near population centers, although USAMRIID, that's military, and it wasn't as populated an area when they started, when they built it. But nonetheless, there aren't many of those because they're so hard and expensive to build and maintain and equip. It's not easy to work in a BL4 lab.
So is there, because of all this conversation around, like that this was intentional, that the Chinese put it into the population, we're off of that now. It's not intentional. Everybody has agreed there's no intentional release. Oh, okay. Because I've read some things that people still think that it is.
Oh, well,
is there conspiracy theory, right?
China,
but is there a way to actually disprove that scientifically?
Well, we've disproved scientifically that it's genetically engineered. A deliberate release out of a BL4. We can't say, we can't, we can't say. I mean, there could have been a mentally disturbed person who did it
Yeah.
intentionally. But why I think that's, well, okay, if the person who runs the lab is telling the truth that it isn't a laboratory strain that they maintain, and they can check that. It's easy to check.
Mm-hmm.
If they're lying about that, then all bets are off. But assuming they're telling the truth, then there's no way to guarantee what you're going to get infected with if you try to infect yourself and bring it outside. Like that has always been feared as a possible spread, like for suicide bombing. Infect yourself with smallpox and spread it around. Could be very easily done if you can get a hold of the pathogen. Most of the stocks are destroyed, and they're only under the tightest security in like, I think it's 3 places on the planet. However, you know, if I'm a little tired, a little careless, I want to get out of my spacesuit faster, or I never put, I worked on a bat in an ordinary BL2 lab. You know, BL4 labs aren't usually just BL4. They have all levels in different wings and such. So if a bat came in and, you know, maybe the bat was just being logged in and somebody got some virus on their hands and the rest is history. You know, I don't know the process. I mean, even collecting the bat should be done carefully with protection. And it could have been the seafood market. The interesting thing is the first patient to become ill and show up, patient 0 as we call them, didn't have anything to do with that seafood market. So that's already an indicator that there was person-to-person spread, right? So people from the market came in later, like not patient 0, but the next 6 cases all had an association with the market. So, you know, I'm hoping it doesn't turn out to be the virology lab, although I don't know how we could find out if it was an accident. I mean, it might be if we can't get access to this, but if the Chinese were to let people know how many people who worked in that institute handled these animals, how many of them sickened, you know, and did they live near other clusters? Because what seems to be interesting is cases aren't randomly just distributed everywhere, even in non-hotspots. For example, in DC, we've got a couple of like mini hotspots that started from, I think, one person at the Biogen conference in Boston and another at some religious gathering of pastors where there had been infected people. So, you know, it's like, do we see that there's a cluster that started in this virology institute? There are ways we could make inferences, but with the data we have available right now, we can't say it all. Was it the market? Was it passage through a pangolin? How many people did it have to go through, or how many animals did it have to go through to adapt itself so that it could bind well? It binds decently to our receptor, but not great. It could be better. And that's why it frankly couldn't possibly be engineered, right? I would have done a better job, you know? So again, I think everybody's off of it's a bioweapon idea. And was it an accident? I can't even fathom deliberate release assuming it wasn't one of the lab strains. Or was it the market and pangolin trafficking? We'll probably home in on it better over time, but for today, we just don't know.
Well, it's cool that those papers those white papers that you've looked at have already been published. Like there is some of that scientific.
Oh, things are coming out now. We're really starting to see that the pipeline. I can't even keep up with the research, frankly, and it's really fascinating.
Wow. More bedtime reading. So if anybody has questions, please put them in the Q&A so that we can answer those questions. And if you just want to say hi, you can do that in the chat. If you are watching this on Facebook, please put any questions that you might have in the comments, and I am monitoring that. Karen, why don't we maybe at this point while we're waiting for some questions to come in, talk about the question that I had for you today, which was based on that article in the Atlantic.
Okay.
About test positivity.
Okay. Sure. What the article in the Atlantic had said, and this is true, and we know this. Generally speaking, when anybody goes to get a test for anything, the vast majority of people are going to be negative, right? You know, you don't go in, like most tests are negative, any kind of medical test you're going to take. But if you restrict the population to be tested to just be people who are 98% certain of having it, right? If people have all the symptoms, they're having difficulty breathing, there's very high probability that there is COVID. And we are seeing a very high, what we call test positivity. There are some other places, and it's different, like the average in the US is about 20%. It's a very bad sign that shows we're not testing well, and that we're kind of biasing our testing towards very sick people, right? So we would want to see that below 5, 5% positive test positivity, even lower, maybe a couple of percent, to really feel, okay, we're doing adequate testing to have a sense of what the true population prevalence is. And there are places higher than 40. There are counties in New York where the test positivity is 40%. Does that mean 40% of people, have COVID, in that locality have COVID? No, we have no idea. We're just taking all the sick people and testing them. But as I said, the data from the Icelandic and German studies are very suggestive. We've got a ton of penetration. There's a theory this virus was circulating in December, and that, frankly speaking, a large majority of cases are asymptomatic, which does jive with the fact that the receptor isn't perfect for us. It's good. It's a pretty good binding, but it could be better. Now, I see someone is also asking, why do these come out of bats? The bats have a very interesting innate immune system. And it does nothing to the bat. We know that what determines who can get infected, which animal can get infected, it has to do with the surface receptors on the cell where the viral attachment protein can bind and then internalize into the cell. You've seen those little crowns on the coronavirus virion. Those are called the spike. That's the spike glycoprotein. And that is what binds at the ACE2 receptor. Now, when it binds at that receptor, it triggers a cellular process to internalize that into the cell. If it just bounces around on the surface and it doesn't find an ACE2, it's going to deactivate. It's going to be scavenged by a phagocytic cell. The immune system is going to get it and it's out the door. It has to get in faster than it gets recognized by our very first line of defense, which has some general pattern recognition features. It's not specific like our adaptive immunity that we get from either having the illness or having a vaccine against it. So COVID can get into it. We believe it came out of something that looks like a horseshoe bat, like there's a 96% similarity in the genetic structure, and it went through an intermediate host, maybe a pangolin, small mammal, who knows? We know that SARS went through the palm civet cat, and when they got the cats out of the market, it completely disappeared. We know that MERS, another nasty coronavirus, far more fatal than this one, came out of a camel. So it really depends which animals have that receptor. And it's not every animal on the planet that have the kind of receptor that you need, for cell internalization. Cats and dogs, cats have their own coronaviruses. There's a kind of a nasty disease of cats called feline infectious peritonitis. It's an alpha coronavirus. But it's not as if we're not going to get it from our cats and dogs. We have seen, there was an example of a transfer, I think it was at the Bronx Zoo, that a zookeeper who was sick apparently gave it to one of the big cats. The cat was coughing, and they had 4 cats who were coughing that this zookeeper had fed and taken care of. One cat was tested and he came out positive for the human version of the coronavirus, though it's assumed that all 4 cats had it. Now, generally, and it was, I guess in the cats it was mild. They got like our mild coronaviruses. There are 7 human coronaviruses. I think 4 of them they give us the common cold. They're nothing serious. Now the scary thing is we're also seeing something in the very ill patients. We have ACE2 receptors in the deep parts of our lungs, which is why this disease gives us those bad respiratory symptoms in the severe and critical cases. But we've got those receptors in our heart, in our kidneys. We're starting to see a little bit of myocarditis, a little bit of renal disease. And again, generally in people with underlying problems to start with. We're not seeing this get very severe in young, and by young, under 50, younger, healthy populations. And there was one study, this was fascinating, and I have to see the follow-up, but one study was looking at asymptomatic people. I don't know how many they tested, I don't know where they did it. I think it was China. But they found that the median age of the asymptomatic people was 14 years old. So the kids aren't getting it, all right? And that could be a real key, like why aren't the kids getting it? Although, of course, we've had deaths in 12-year-olds and such, but if you're 8 years old, you're pretty protected. If you're 80, you're not.
Mm-hmm. Karen, I just want to go back for a minute to the initial part of this conversation, which was the test positivity. Do we complete that? Was there anything else about?
Yeah, there's nothing much more. High test positivity generally is a sign that you don't have a good handle on the prevalence of the infections in the place where you have high test positivity, because you shouldn't be seeing that. What it says is we're only testing people we are already pretty sure have COVID or look like they do. Like your 85-year-old friend, if they're not going to test her, probably if they're not, maybe they're not testing unless you've got to be hospitalized then and there. I don't know, but that person obviously should have been tested if there had been enough kits and so forth.
Marisa, if you're still here, I'd be curious to know if you decide, because I know last week when we were on, you were talking about the possibility of getting the test, and we never talked about that. I'm wondering if you actually got the test or not. Let us know. There's a question here from Arnie Polson. Can you comment on the probability of getting COVID again after having recovered from it?
Yeah, this is a really interesting open question. And what I can say is we have seen cases like people are returning for tests and testing positive after they tested negative. Okay, first of all, a couple of things could be the case there. Coronaviruses tend to hang out in your body a long time, okay? We see fragments of coronaviruses well after recovery. We don't know if they're infectious. Massachusetts wastewater is surprisingly high in COVID fragments, and these are obviously being shed through the fecal route. So people who are coming back, maybe with symptoms, the question is, did they clear it? There seems to be some anecdotal observation that people seem to get a little bit better and then they get worse again in some cases. And sometimes that worsening does lead to a severe outcome and even death. But there seem to be ups and downs with the virus. And are the people who are coming back simply they hadn't fully cleared it? And again, there's a lot of false negatives. You put that swab up someone's nose, if there's no virus right there, if it isn't in the nasopharynx, if it's already deeper in the throat or even the lungs, it'll show up negative, but you're really positive. So that can't be avoided. So some places are, if we had enough kits, we'd sample the mouth. We might even do stool to really, look for it in different places. There's even a way to like get it out of the lungs from bronchoalveolar lavage. A little bit invasive, not generally done on people that aren't in pretty serious shape, but there are different places to sample. So we've heard reports of that. But I'm encouraged by a couple of things. One, we know that immunity to SARS, which is a very close cousin of this one, lasts probably 2 years. That's about the length of, if you got SARS, you're protected for about 2 years. If you got MERS, I think it's about 3 years. Now, also, interestingly, we were able to get those viruses out of the population. And there weren't, as far as we know, there weren't asymptomatic carriers. We could get, say you've recovered from it, and then you get reboosted by exposure to someone who doesn't know they have it. You're kind of like augmenting your antibodies, and you're extending your immunity a little bit. So that gives me hope that we'll have immunity you'll have immunity if you got it, and the vaccine will give you immunity for a period of time. They did a test on monkeys, okay? They gave the monkeys the virus, they all recovered. The monkeys were re-challenged a month later with a pretty whopping dose, the kind that might have even killed them if they had given them that much the first time. But certainly enough to, see if they had immunity. None of them sickened, okay? So
that's a good piece of information.
That's interesting. I mean, again, it's a small study with a few monkeys, and we're looking at animal models. Ferrets apparently are also going to be good models for coronavirus. But the true answer to your question is we don't know yet. It hasn't been long enough. And I don't know. We have had people coming back to hospitals in Asia. But the question is, had they fully recovered? What's the issue? Because the coronavirus does hang on, and it can do things in other parts of the body. I mean, it's a lot of receptors in the GI tract, a lot of, receptors in different organs. So the jury's out. And I think there's reason to be hopeful, but we'll just have to wait and see.
Karen, how long is that immunity for like influenza A and B? The reason that I'm curious about it is, we found out that Adrian, my son, did not have COVID. He must have he had the flu, right? Mm-hmm. Some flu in early February, whereas I did not get sick at all.
Uh-huh.
And do I have an immunity from childhood, or is that would I have to have
you absolutely immunity? Could have. You could have had the immunity. There's a couple of possibilities. And what I want to really emphasize for those, I know some of my students often come to this, and they could certainly say, whenever you think about a pathogen, absolutely, a pathogen has its way of harming a host. And a viral pathogens, it's all dependent on what we call the tissue tropism. Where can that thing bind? But the key is there's a war. The minute that pathogen enters the body, the immune system, which is our best killing machine ever against pathogens, is on the case. Now, every human is genetically different, health status is different, age, everything, immune status. So every war that this coronavirus fights is a different war. And, some people, the older people, those who are unfortunate enough to have what's called the cytokine storm, which is an immediate and aggressive innate immune response, which then entrains. The innate immune response is like our first line of defense, and that clears a lot of stuff. So if you didn't get a high dose from Adrian, maybe that mopped it up and you didn't get it. Okay, so you did get a high dose from Adrian. you could have been exposed to that same virus. You could have had it last year or when you were a kid or at some point in your life. Let me use pandemic influenza 1918 as an example. One of the reasons we believe that the older people were protected, that was like the strange W shape. The super young and the super old always die in these kinds of things. So they were harmed. But people between the ages of 18 and 45 were the hardest hit, the strongest immune systems, the most robust. It was believed that about like the 50-year-olds and the 60-year-olds had some partial protection from a similar circulating strain, 40 to 50 years ago when they were kids. And there's some interesting evidence emerging that what you get exposed to as a kid and what you get vaccinated against as a kid can really hang on in some cases. So let me tell you an example. Let me tell you about flu 1918. It was fascinating. The first wave was in, the spring of 1918, and most people didn't even know about it. It was effectively in military camps in the US. Went a few places, but not very far. It was mild relatively. And most of the public wouldn't have even heard that there was a wave of a pandemic. The real wave hit in the fall. And that wave, if you had been sickened in the spring, you had better protection from that than you had from a vaccine, okay, that we have today. So the people who got it in that very first round and then, got exposed again had tremendous protection. Then there was a final wave in the spring of 1919, and neither having it in one of those times, if you had it in those two times, you didn't have particularly good protection against that third wave. Now, people have suggested, was it just what we call antigenic drift, some mutation, which happens a lot with RNA viruses? Was it a reassortant? Something happened to change that virus. And some people with reason claim it wasn't exactly the same strain, and maybe not, maybe it was a reassortant, but it probably was the same that had just mutated a little bit more.
Fascinating.
And that was also a much smaller, like people had caught on to public health by then. So the first peak was very small, second peak huge. I mean, it could kill within 24 hours of infection, and it had killed 2/3 of the people who got it. Okay, that's a different situation than what we're facing now by a long shot.
And Karen, didn't you say the other day that your grandfather died from the Spanish flu?
Yes, absolutely. My great-grandfather.
Great-grandfather.
And it changed our whole family's trajectory.
Right.
Because of that. And Boston was an epicenter. My hometown of Boston was one of the epicenters. There was one in Africa, in Freetown, Sierra Leone. There's also, people are reevaluating all the time. And we used to think that virus started in Kansas, actually. But now there's some new thinking. Most flus begin in Asia because they're bird. We think now, we used to think that we got it from swine. The evidence is accumulating that we gave it to swine, okay? So 3 groups: waterfowl, swine, us. We share our flu viruses. Chickens are also in the mix, and because of the way animals are raised, where pigs and chickens are on the same farm in China, that's been, and how the chickens, they used to like stack chickens in cages and the feces would drop down, and that was a real recipe for disaster for spreading flu. That's all been changed, but animal husbandry practices, so flus tend to come from China, and now we're starting to think that 1918 flu really came from China because their death rate was surprisingly low. So there was belief they had some protection from a close variant that had been circulating earlier.
Okay, so why is it called the Spanish flu then?
Okay, that is a story that I never call it the Spanish flu because it's so unfair. This first, it was really that fall wave that people, were keyed in on. But even before that, World War I was going on, okay? And during World War I, there was a press blackout in all the countries that were fighting the war. France was very badly hit. England was very badly hit, worse than Spain. But the Spanish press was reporting it. So for that reason, oh, it's the Spanish flu, it's in Spain. In fact, it was in the US months earlier. It was in Africa. It was everywhere. And,
That's so
it's
fine.
sort of unfair but that
Right.
is why they call it the Spanish flu.
Because they reported on it.
Exactly. And one thing that's also interesting in terms of public health, there was a great book written, I loved it. I studied 1918 influenza. I read all the history on it that I could lay my hands on that wasn't too dry and boring. So this guy named John Barry wrote a wonderful book called, I think it was called The Great Influenza. And what he talked about, like all the public health measures we have today, we learned then. And there was one really, really interesting critical thing. And San Francisco behaved well then as it did now. That was a model city. And it was kind of like the government and the journalists were in cahoots to try to minimize it. And where that happened, where the public lost faith that the truth was being told, you had chaos, you had social breakdown. In San Francisco, where the mayor stepped right up and said, hey, we're a mask, save your life. This is not seasonal flu. This is not like what we've seen every year. This is different. And the other studies were saying, oh, it's just a flu. You'll be okay if you take precautions. Now that was terrible. And you think there's communication issues now. It was out and out lying back then. And you
That's
saw
funny.
a lot. So people would isolate more. And in San Francisco, when they closed down the schools, the teachers stepped up to be ambulance drivers and to help out. They knew they were putting themselves at risk, but they knew they were being told the truth. So if there's one lesson from that at least has been taken on board, and the Chinese should listen a little more, is absolute transparency. If you don't know, say you don't know. People were seeing that their friends and family were dropping like flies, which isn't usually the case with a seasonal flu, particularly for, healthy young adults. So they knew this wasn't flu as usual, and they just resented being lied to.
Right. And wow, that was you said 3 out of 4 people died? Was that the number?
It's on 2/3. Two-thirds.
Yeah.
But
that's incredible.
And the time it took to kill you, literally, it was in all the Army bases in the U.S. and it turned you blue. We didn't have ventilators, we didn't have nasal cannulae then. Literally, doctors would say they couldn't tell the difference between a Caucasian and an African American because the whites were so dark. They had turned blue.
Wow.
So their whole bodies had turned blue, like the lips and the fingers. The usual things go first, but their whole skin, they just wasn't getting oxygen. And this could happen. You could be healthy in the morning at 8 o'clock and dead by midnight.
Interesting. So in some ways, we're lucky with this one.
Oh yeah,
this is a major wake-up call. Major wake-up call for our public health, as you've been talking about all these weeks. And maybe we all have become a bit complacent. That's just
and that's because science.
In our lifetimes we had never seen anything like science.
We haven't seen it. Science did. We have a lot to thank. Researchers, medical professionals who toiled and just made it possible for us to get complacent. A day will come when we can maybe say that we've licked it or we understand it or we can respond immediately, but we didn't believe that it could still happen, and it can. And we are lucky that it isn't as bad as 1918 flu.
Wow, we're
super lucky.
I have a
At-
question from Facebook that
Oh,
I'd
okay.
like to ask. I don't know if she's still on. Marcy is asking, people are getting tested for the CV antibody. Majority of these people are healthy. Should everyone get the test?
Okay, the thing about the antibody, a lot of the tests aren't that great, okay? Many of them are coming in from China. They've not been FDA approved. They're not validated. If you can get one and it's available, why not? The NIH itself was going to test 10,000 people, probably randomly. They're doing a big antibody test right now to try to ascertain prevalence, obviously with some of the best testing kits available. They were recruiting 10,000 subjects, and you had to just send an email to clinical studies unit at nih.gov, which I did, and I volunteered, but I didn't get selected. I suspect they found the 10,000 people very rapidly, and I also suspect they probably want to sample in the states where the hotspots are, to really get a sense of how it really had spread. That might be, if I were doing it, I might focus a little bit on that. Ideally, if you could get it and learn something, if you have IgG antibody, you've got some immunity. Wow, great. If I could get that test, I would, but I can't even get out of my house. I
Ah.
get it.
Yeah, I mean, I was glad, Marcy. I don't know that you were on last week, but I got a test for Adrian, and I was glad that we got it. I mean, it was good. Supposedly the test that he took is pretty accurate. Who knows? But he came up negative, both for the disease itself, current disease, and antibodies.
Yeah, because the IgM is like the early antibodies without as much specificity.
Right.
The IgG are the protective,
Yeah.
immunological memory.
Yeah.
So,
I don't know if I still have that here, my test. Oh, here it is right here. Hold on, please. Let's see if I can get it here.
Can you get one for yourself too?
Maybe.
Yeah.
Maybe. So that's, I don't know if Marcy, you're still here, but that's what the tests look like. And it's just droplets of blood mixed with some solution. And I'd get it. If I could get it, I would get it. I think they should be passing these things out like candy.
I think so too, and they will once they get enough of them.
Yeah.
Once they get
it's
enough,
easy enough. You don't need to go to the doctor to be tested.
Exactly.
If you can read directions and you're willing to prick your finger, everybody can get this test.
What people tend to fear is that, there's tests like this for almost everything now, right? But they don't want people panicking. This is it. Like, if you're totally healthy and you've got antibody protection, great. I suppose if you just saw IgM, you might panic and think, oh my God, I'm just barely I'm going to be symptomatic. So that's usually why they like
So it's a good piece of information, right?
Well, I mean,
by the way,
for most of us, right?
I really had a funny joke that I was going to tell about pregnancy tests.
Well, this is it. I mean,
if anyone's taking a pregnancy test with a potential unplanned pregnancy,
well,
talk
that's
about
true
panic.
Well, that's true too. But there's
not saying that I have.
No, you've got a point. You definitely have a point. But there's a course of action that can be taken.
It was still good information to have.
Very good information, right? It's good information. Yeah. You're right. What I'm just fearing,
my pregnancy test is now in the other room.
Well, what I'm thinking
as an almost 12-year-old.
Well, yeah, you knew you were pregnant, right?
I did.
Oh, I was pregnant. Well, on the other hand, look at people poisoning themselves with hydroxychloroquine for their tissues.
Yeah.
If someone saw that, would that spike us up on kind of that kind of inappropriate and dangerous behavior? So, I mean, these are all decisions. I mean, this is way above my pay grade. This is what public health professionals weigh back and forth. And I think doing it at the workplace where you even have a volunteer who's been trained, who can talk to you, I think, that would probably be just as good, and it would minimize the risk of panic and deaths from self-treatment, right? So
Yeah. Well, especially if there's not, the treatment's not really totally
right,
important
when
to
there's
us at this point.
nothing, it's not clear what's going to
Yeah.
happen or if the treatments are going to work for you. It's
Because now with like malaria, they have these tests, and there's also
and you
treatment,
can buy them, yeah.
and there's
And
also
you know what
treatments
to do.
available. Mhm.
Absolutely.
Yeah.
And malaria normally isn't very fatal, at least not unless you're a kid. It's young kids that
Yeah.
are.
Yeah.
So it's a different situation.
So in terms of testing, I have a question that came up when you were talking, because you're talking about all the different like the things you can test in the body, right? The nasal passages, um, fecal matter, the blood. Is there something that's preferred? Like, like this test that Adrian took was a blood test.
Well, that's where you'll find the antibodies. For antibodies, you've got to do it that way.
Gotta
What
have
they're
a good blood.
testing in the saliva, it's really deep, it's in the nasopharynx. They're doing a PCR test, a genetic test, looking for the genome of the virus.
Okay.
So that's a very different style of test. If there's virus, even in very minute quantities, that test will pick it up.
So that's interesting, right? Like the ancestry.com and the 23andMe. So this the saliva test that you take, and it tells you all kinds of probabilities. I never did. I did the ancestry. I did not do the 23andMe, but I know 23andMe gives a lot more like information.
Right, that's a totally different thing. I did the 23andMe for the health, and basically what it's telling you, it's a very different thing. Obviously, when you scrape some of your cheek cells and just spit into the little tube, there's tons of your personal DNA in there.
Yeah.
And they're looking for what we call SNPs. And these are like point mutations in the human genome that sometimes are associated with characteristics. Very few of them are that relevant. I mean, there's like what mine did very well. It predicted my skin color very exactly. It told me I have a sweet tooth. There's 20 genes for sweet tooth, and I think I got every last one. It told me things about how fast I metabolize caffeine. They're kind of very random things. They can also tell you if you've got things like the BRCA1 mutation for, higher propensity for breast cancer. In fact, 23andMe was shut down for a long time because they were able to tell you had some tendency towards very serious diseases, and then there'd be no counseling for you. Do you want to learn that you could get Huntington's and then you're just reading it on your email? I saw that one thing though that I did get, that I was surprised how much it pleased me or how much it relieved me. There's a ton of Alzheimer's in my family, and we know there are 3 alleles, 3 forms of the ApoE gene in the human population. Well, actually, yeah, there's ApoE2, which tends to be very protective. If you've got 2 copies of ApoE2, you probably aren't going to get Alzheimer's. Now, ApoE3 is kind of a middle of the road. It's not a high risk allele, but ApoE4, that is strong propensity. That's the risk allele for Alzheimer's. If you've got 2 copies of those, well, does that mean you'll get Alzheimer's? Not necessarily, but it certainly enhances your probability that you will. Now, I always assumed I had at least 1 copy of it because of how many people on my mom's side, I will say, but it turns out I didn't have that one, and it pleased me.
Yeah, I can imagine.
My mom would have had it by now if she were going to get it. I mean, her family members got it at younger ages than she has it, so she probably didn't get the ApoE4, and her mom did, and her sisters did.
Wow.
and she's okay.
So at some point, would a 23andMe be able to detect if you had the
No, they couldn't.
antibodies?
No, because 23andMe is looking at your DNA, whereas the PCR test is looking at the virus's RNA. The virus has
Ah,
its own genome. Every organism that can replicate has to have a genome. So it has a genome that's based on RNA. We have a genome based on DNA.
DNA.
A
Got it.
slight modification, just a slight chemical change, very similar molecules, but just a little different.
Fascinating. I should have paid more attention in my science classes. So do we have any other questions? Because we have no questions in the queue right now. I don't necessarily have any my big questions that I had, Karen has answered. So we'll wait for a few minutes to see if anybody else has anything that they'd like to either
We can end a
share
little early
or ask.
today.
Yeah.
I can also tell about another study. This one
Sure.
is maybe kind of, this one, I think there's a lot of solid evidence. And this is the protective effect of vitamin D. Let me just say, everything is tentative and we have to really do the exact experiment, but vitamin D has long been known to be protective of respiratory infections, good levels of vitamin D. And we know that the mechanism, at least partially, has to do with modulating interferon 1, which is the cytokine that actually kicks off the cytokine storm. Now, there was a very theoretical paper with a lot of assumptions, but what this group did, they looked at two sets of countries. Now, some countries tend to have averagely high vitamin D levels and averagely low vitamin D levels. So they compared the mortality. They compared the mortality per unit of population in these two countries. And they found that, yes, indeed, on average, in the countries with lower vitamin D levels, there was higher death rate. And that was even corrected for vitamin A and healthcare access. So that is quite interesting. And what this group did, again, lots of theory, what the group estimated is that a good 15% of the difference in mortality between the two countries could probably be attributed to vitamin D.
Interesting.
So if you have vitamin D, if you have low vitamin D levels, and that's a lot of women, I was even taking 1,000 units a day and was still below the normal range. So I had changed that a few months ago, but vitamin D is responsible for an awful lot more than just bones and teeth, so just, I had mentioned this once before, but I thought that's worth thinking about. If you have low vitamin D levels, you might want to start working on that. And particularly when we're indoors, we're not even getting the sun out to do the conversion for us through the skin. And with the vitamin D, though, it's a fat-soluble vitamin. You can get too much and it can be bad for you. So that's the thing. You don't want to go crazy with vitamin D. You just want to get yourself into a good range.
Thank you for that reminder. Oh, Marty's back. Hey, Marty. Marty's on Facebook Live. Do you have any questions for us? Because we're about to wrap up. Interesting to know about the vitamin D, because I have in the past tested low for vitamin D, strangely, because I live in Southern California and I spend a lot of time outside. But maybe it's about the way my body processes it. I do have the 1,000 milligram drops, and I had actually gotten a new supply of it when Adrian was sick early in February with that flu that we had hoped was the coronavirus. And I was, dosing both of us with that every day, in addition to vitamin C, and a couple of other homeopathic, defense kind of things, just to keep ourselves healthy, in addition to eating a ton of vegetables and fruit.
Well, that's always
and so, that's good to remember, because I think I've slid off of the vitamin D, so maybe we'll go back to that, because certainly now that, things are going to open up,
Mm-hmm.
and we're going to go all get back out into the world in some sort of way in the next month or two. We're going to we're going to have to be strong. Marty just asked, did you guys talk about a resurgence? I guess we did talk about it, but we talked about it, Marty, in relationship to the flu of 1918. And we did talk a bit about it a bit, didn't we? Is there anything else you want to hit upon with that on a resurgence?
Well, we're seeing a resurgence in China from people bringing it in mostly from Russia. So, and in fact, Africans are being beaten, and African students studying in China, there's a ton of them. And the xenophobia right now in China is terrible because they're being accused of bringing the virus into the country. But yeah, the Asian countries that have tackled it are now seeing their cases spiking back up, but they're imported. They're not generally coming from, it's not local transmission. But yeah, that's happening.
So
and they're getting on
coming in from outside, not inside.
Yeah,
mm-hmm.
It's coming in from outside.
But that hasn't changed their trajectory.
But it isn't terrible. No,
mm-hmm.
It's not terrible. But there are new cases, and those new cases just demand a public health response. But there's a small enough number of them that they've changed their quarantine rules at ports and stuff. So they're getting on top of it. We're seeing more cases, and they're imported cases.
Well, that's it. Then this is a great question to sort of follow up with that. Reginald asked, what protocols do you think should exist in our airports and transit points post-COVID-19? If these should prove to be invasive in terms of privacy, what would, in your estimation, be the right compromise?
Well, most of them aren't terribly invasive. And one thing they're doing, and I know that in some places, they're even doing this. A colleague of mine in Ghana told me that they've even got blockades set up coming into towns where if, the police will stop you, they'll, use those gun thermometers, they point it at your forehead and, take your temperature. What they're doing is if you're coming in with a fever, they're obviously going to direct you right to the hospital. They'll escort you there because you have to be looked at. You have to be tested, okay, at least. And what most countries are doing at airports is if you're coming in from where there's active cases, particularly anyone coming from the US, is required to quarantine for 2 weeks. If it's been 2 weeks and you've not become symptomatic, either you were an asymptomatic carrier and you don't have, you're not going to get sick, or number two, you're okay. You just didn't get exposed. You're not infected. You're not at risk of harming the population. Now, the way it's been done in most countries is you have to quarantine at your own expense. But I think that is reasonable because that's exactly how certain countries even got their initial cases. It was coming in from hotspots, and there was no testing. The people came in. There was even an example of one tourist who contacted 1,100 people, and they had to go to all those, and say, hey, you've been exposed. And reality is, it's just not even practical. But in a time like this, when you could potentially be sickening and even killing people, I think, first of all, the airlines warn you. If you're going to get on a plane to a destination, you're informed of what will happen. So if you try to go, even if you're going home to your own country, you may have to quarantine for 14 days, either in a facility provided by the government of that country, or some are allowed to do it in certain hotels at their own expense. Hotels that have been basically shut down because of no tourism are making their facilities available to quarantine people for a fee, right? So I think that'll do it. That will solve the
Well,
problem.
if you know that's your part of your ticket, right? Wherever
Yeah, you're
wherever it is that
told.
you're
I mean,
dreaming to go. Yeah.
you're told, and you should expect this. And honestly speaking, you should even want to do it voluntarily, because tourists started, I mean, that started the US outbreak, right?
Mhm.
It was basically Chinese Americans. They're Americans coming home from a vacation. Sure, they have every right to come home, but they came from Wuhan. I mean, part of the issue was the Chinese were not totally upfront about how serious things were. And to this day, we don't think we have accurate case numbers or fatality numbers, even disregarding the fact that there wasn't testing and criteria changed. China has probably suppressed a little bit the true extent of the problem. Now, had we known that, people coming in from Wuhan would have been quarantined and would have.
Right, because they have those cases, right? Like there was the nursing home in Seattle and Washington was a young guy that came in from Wuhan, wasn't it? And
I
then
don't
also
know.
in New York, there was a gentleman who had come from Wuhan, and then he went to a lot of different events and things. And
Really? I mean, I know the
yeah,
New York case was mostly seeded from Europe by Europeans.
yeah,
They were coming in at really the height of, we didn't close the borders to Europeans, I think, until, was it like around the 12th of March? But we shut that down. I mean, you couldn't even come in from Europe.
yeah.
So these kinds of restrictions, airports are shuttered in a lot of countries. And given what we're looking at, until we know more, once we know more and know how, once we have a public health infrastructure in place where we can test and track and protect the vulnerable, I think we'll have to make these sacrifices. Now,
Yeah.
clearly, we've got to get economies going again, or people will be dying of starvation, or, there'll be a lot of other hardship and death from, secondary effects. So we really need to get testing ramped up so we can start knowing how to ease things a little bit.
So Marty's got a couple of questions I might need to clarify. And while I'm looking at her questions, I want to ask you a question about, I got a message today. I get messages from the city of Santa Monica, and I got a message saying that, I'll actually read it so it's actually an accurate depiction.
Okay.
And this is the first time I've seen this. Oh, oh yeah, here it is. Okay, so it said, every day they send something about COVID. And this is for today, county state report increases in COVID-19 deaths. Santa Monica has over 100 confirmed cases. This is a critical reminder to abide by the stay-at-home orders.
Okay.
So my little city, I think we have 90,000 people here, has 100,000 cases. But obviously it's a town that gets a lot of traffic from elsewhere.
Right. You're
tourist
very
destination.
Exactly.
And we're a little bit of an island.
Well, and
a lot of
another
people come in
thing,
here to work.
okay, 90,000 people, and you're only talking 100 confirmed
Right.
cases.
Yeah.
So there could be 1,000 true cases.
Yeah. Yeah.
But 1,000 in 90,000, that's not too bad as compared to, some of the places we're looking
I just thought that was an interesting statistic.
Mm-hmm.
Let's see.
That's good that your city's doing that. I have to go online and check it.
Well, that's the first time I've seen a number, but our city has done a great, and by the way, on Friday, our city manager resigned. There's a major hubbub that's happening in Santa Monica right now about not being able to balance the budget. And so resigning, which was a problem that was happening prior to COVID.
That was before COVID.
And COVID has simply exacerbated it.
But COVID is certainly not helping the situation.
Yeah, I mean, it's who knows? I'm not into the budget of it, but I just have a hard time believing with the development that's happening in Santa Monica that there's a money problem. But what do I know? So Marty is asking, let's see, are there any new symptoms that are happening around COVID that we've heard about? Like, We didn't know
Yeah,
before?
probably Marty, you weren't here when we said we're starting to see myocarditis. We're starting to see renal problems because there are ACE2 receptors there. Now, this is not by any means huge, but it is cropping up. And it was expected. I mean, we were looking for that based on the tissue tropism of this virus, which is dictated by the ACE2 receptor. And they're in the heart, they're in the kidneys, there's lots of them in the gut. So yeah, there could be some more GI type things that are going completely unnoticed because you wouldn't even think it was maybe COVID. But yeah, there was a lot more of that with SARS. But yeah, I mean, I think we've seen the it's been long enough, we've seen the range. We've seen a range of presentations. And as we were talking about earlier, it's a war. You know, there's the virus on the one hand, which has an intrinsic ability to do certain things. And how much of a dose, like how many soldiers got sent in? You know, did you get a little dose? Did you get a massive dose? And then there's your immune system. And your immune system is going to defeat it. You know, you're healthy, you didn't get a big dose. This is the winner, you know, you're young by far, right? But every battle between the virus and a host immune system is unique to that host. And your status, your general health status, we're seeing that obesity is a real problem. And that's just one more reason I'm glad to be doing BLE, you know.
Right line eating, PSA.
Yeah. So obesity is a risk factor because obesity kind of puts you into a pro-inflammatory state. Obesity causes inflammation just intrinsically. So
not to mention typically what you might be eating when you are obese, right?
And God knows, yeah, God knows what kind of junk. Like I certainly am a veteran of the junk food wars. So yeah, if you're not well nourished, if your health status is poor, your battle, you know, you've given the enemy a couple of legs up, right?
Yeah.
But still, the immune system is extraordinary, you know,
So just a couple of things on as we're winding down here, it's 1:26 Pacific Daylight Time. And it's kind of going along lines with Marty's final comment, which is, you know, it's interesting that people in America believe that we're overreacting. And so it's kind of this combination of like, the question is like, are we overreacting? And I think I know your answer based on these conversations we've had. But now there's this whole thing that we're seeing where people are really trying, you know, there's a woman in Canada, I don't know if I mentioned her last week, and I've started seeing on social media and things, like people saying like, we have the right to like get this disease now. It'll make us stronger than any immunization will make us, you know, that kind of, like we're seeing that. Anyway, thoughts on that?
Well, if you really want that, just go into an emergency room and get it, right? You know, go into a hospital. It's a place where you're likely to contract it, you know. Honestly, we underreacted early, okay? In January, at least in the US, I don't know for Canada, at least in the US, we had all the information we needed, and Navarro was jumping up and down and waving his arms saying, we got to act. We did nothing. I mean, we didn't take it seriously much at all until the end of February. So we let a month go by. So because of our early underreaction, that sort of triggered, I mean, I don't know if I want to call it an overreaction, but it's the appropriate reaction when you let it go too long and it was already too deeply disseminated in the population to control by testing and isolating. And we didn't have the test kits anyways. So frankly, I don't think it's an overreaction. I mean, we're learning step by step. And a lot of what we're learning came from 1918, which was a far worse pandemic, a slightly less contagious disease, but a far more fatal one. So these are tried and true things that we know will help. again, there is that balance. I mean, the economy, I mean, if you really want to get coronavirus, I think you could probably get it, just go to New York City. I mean,
Right.
if, no one is preventing you if you want to violate the stay at home and go to a hospital and breathe deeply. You'll probably,
I like that. Like, go get it. Go out and get it.
I just don't consider it a human right to get coronavirus, right? I mean, and I don't consider it, particularly if you could be a vector to me, I think that kind of desire, it's like the spike would have collapsed the Canadian health system. Do you want that to happen, not just for virus patients, but everybody? I mean, these kinds of requests don't make sense to me, honestly.
Yeah.
Sweden took that view. Remember, we talked about that, I think, 2 weeks ago. And now Sweden has the highest death rate of all its neighboring countries. It's ripping through nursing homes, and let's see. I mean, at the end of the day, they built like field hospitals to deal with the surge and overflow. So time will tell for them. We'll see. Brazil did the same thing. I mean, I think at this point, it's kind of new to everyone. We haven't seen anything like this since 1918. We're all learning, we're all learning. And I'm very, mistakes have been made, and there'll be a time to really look at how and what to fix. But throwing blame around and, overreaction, I think I'm willing to overreact to protect our most vulnerable. And maybe in retrospect, we did.
In 1918, was there stay-at-home orders? And
oh yeah, they knew about social distancing. They knew about stay at home. I mean, if you had a death, you'd hang a white flag on your front door and bring the body outside and go right back in. It was a difficult time. But yeah, people knew about flu. I mean, flu had been around for ages, and they quickly saw it wasn't typical, and they kind of knew how you got flu even. They knew if you hung out with people who had it.
And then what is one question? A couple questions from Marisa to close, since it's 1:30. Marty, I hope you can hear now. She's saying she can't hear, but she's over Facebook Live. Marisa says, so if there's a resurgence, can we expect the same shelter-in-place order?
Potentially, yes. If there's a new wave in the fall, or if there's a resurgence, but if we have enough testing, which we don't now, and we have enough contact tracing to isolate, the contacts of those who do test positive, potentially it could be a little milder, like there may be stay at home for vulnerable and the others can go out, potentially. We just don't know yet. We just don't have enough testing and tracking to even really start a large-scale reopening right now. I think we're going to be seeing it in mid-May in places not hard hit. End of May, we'll be seeing small businesses. Things are starting to open in Europe, and the way they're doing it, they're staging it. First, the small businesses. Then they're going to give that 2 weeks and see if they see a case spike. If they don't see a case spike, then they're going to maybe do schools and larger businesses. So they're doing it in a controlled fashion so they can say, oh, we've got to stop or back off or whatever. So we're all learning and we're all going, step by step.
And then Marisa asked, she says this may have been answered already, but why was 1918 more fatal in terms of the actual virus?
Oh, we have certain flus just are that bad. I mean, the 2019 swine flu was just like this.
2009?
Yeah, what am I saying? 2009 swine flu is just like the extreme symptoms are COVID duplicates, right? But not many got there. That's the thing, So 1918 was thought to be so severe because it was relatively new in the population. Something had changed. There was a more dramatic shift in the virus from year to year. And it's like this one. it hit a naive population and it ripped through it like a fire through, kindling. And what was interesting, and this is what we think, that maybe that flu really started in China, not the US, which we've always believed, Kansas. It may have started in China because the death rate was lower, so a related virus may have been circulating earlier that mutated. So COVID won't be as bad the second time around, and it's probably now with us in the human population. Because it's so communicable, it won't be like SARS or MERS. You can be spreading it before you know you're ill. So, this is just one more virus. But I'll tell you, I have measles virus in me. I have chickenpox virus in me. I have Epstein-Barr virus in me, and probably a couple OC43 and 229E. Those are coronaviruses. I probably got them in my body right now. We do coexist with pathogens. It isn't always, they're going to kill you the minute you get them. So I think there's no reason to panic. We have a lot more technology, a lot more understanding, a lot more science, but we are kind of taking it step by step. And if we did overreact, okay, I'd rather we underreacted early. So the compensation would have to look harder. If we had gotten on it fast, we wouldn't be seeing New York the way it is. We wouldn't be seeing the numbers we have. Because how can a country with only 300, let's even give it the high number, 380 million people out of 7.7 billion, how can we have a third of the cases in the world? Confirmed cases.
It's interesting. Well, thanks again so much, Karen. This was fun.
Welcome. It's been great seeing you guys again. And
yeah, thanks to all who came. And I think that we'll continue next week. We're looking at numbers and seeing if people are still interested. And it looks like we had a lot of people here today with us. So
yeah, so as long as people are interested, we'll still do it. I mean, there'll come a time when probably we just don't have interest and there's nothing more to say, and we can all go home and get our vaccination.
All right. Well,
okay,
thank you so much, Karen. Thanks everybody for coming.
Everybody, a nice week.
Thank
Bye
you.
Bye.
Bye.